Hi guys, we're back here for our course. In this module here, we're going to talk a little bit about optimization. Let's open our project here, Piano House. While it's loading Unreal Engine, optimization is one of the terms used here inside the platform, inside the Unreal Engine, to work a lot of things uh, with the goal to gain frames per second, FPS. Okay, FPS basically shows us the fluidity. Okay, one of the goals to work with the project in real time. I mean, if you have enough time to do it, uh, to optimize your project, because besides work in an organized way to make your work easier with your assets, to find the textures and everything, you saw that our project uh, now it is already a project that is very easy to get disorganized. Okay, because we have a lot of folders. Okay, a lot of materials. Um, so it's really easy to get disorganized. Okay. Another thing that happens with the project while you're developing the project is like decreasing the FPS. Okay. The FPS, the frames per second, shows us literally the amount of frames that are being rendered. Okay. Here. So per second, uh, it's rendering about 70 frames. Okay, depending on the place that I look at, it can increase or decrease this FPS. Let's take a look here at the sky. 120, because there are a few objects in the scene, okay, to be rendered. If I look, for example, here, a lot of objects here to be rendered, so it's gonna uh, make the FPS get lower. And this is directly related to the amount of polygons that my object has. The more polygons I have, I mean my object, more heavy is gonna be my project, and it's gonna be harder to process. So it's gonna put more effort to process my GPU, my memory, my process. So that's gonna result uh, the time of processing. Uh, it is shown for me in frames per second. I mean, the more polygons I have in the scene, like the more is the resolution of my textures, or more shadows that I had, the amount of shadows that I have in my scene. So uh, the lower is gonna be my FPS. That's how it works. Uh, the better is the quality of my viewport, for example, the lower is gonna be my FPS. Okay. Uh, the lower is my quality in my viewport, the higher is gonna be my FPS. Okay, that's how it works. So inside the world of games, that is Unreal Engine, it's very important that we work in a optimized way, decreasing as far as possible the amount of polygons, the amount of shadows in our scene, the amount of overmaps of these shadows, the quality of the textures. Okay, and just show what is really important. All right. So it's really important to work in an optimized way. Okay. And to do that, there are some features, some resources that we can use inside Unreal Engine. Some technologies, for example, Nanite, that is gonna transform the polygons in clusters, and it's gonna make easier the processing of your mesh. For example, the amount of polygons that you have in the object, there are some features that you can decrease the quality of the texture as I get closer or as I move away from this texture. Okay, and we're gonna see in this course, this module of optimization, some features that we can use to increase the FPS, okay? Or avoid them to get really lower, all right? So let's get started with Nanite. Well, Nanite is the technology inside Unreal Engine 5 to decrease the amount of polygons, transforming them into clusters. It is a technology that Unreal created that literally you can work with objects with infinite counts of polygons. Uh, well, not infinite, but uh, we're talking about millions. Okay, we can transform them uh, like into clusters in objects with minimum counts of polygons, but without like losing the visual quality of this geometry. Look at this. Let's select this. Click here, double click. Let's see the details here. We can see, for example, here in details of this couch, we can see, for example, this information here. Okay, LOD, that is in 0. We're gonna talk about it in the other class, next class. Okay, the current screen size, we can see it. We're gonna talk about it in the next class because it's related with the LOD. And the triangles here, we have like 403,000 triangles. Okay, here. All right. So yeah. So here I have 403,000 plus 403,000 more or less, plus 600,000 plus 600,000 in piano. So you see, we got more than 1 million. So it's important to use Nanite to decrease the polygon count and obviously decrease the cost of this for our GPU, for our memory to process this. Okay, so let's select the couch, double click on it. Here on this interface, we can minimize this or put it here. Let's see. Okay, so you have the slots of material here as we saw in the migrate class. We're gonna associate the correct materials here, and here you have the Nanite settings, or you can search Nanite. Okay, it's right here. All right, you have the option of enable Nanite support. Okay, when we click here, we need to apply changes. Okay, next parameter that is important is this one, position precision. Okay, we have these parameters here that basically says the size of the cluster. We can leave it like this. Okay, and we can leave arranging to decide this based on the size of the details of our model. Okay, let's just click on it and apply changes. Okay, after that you see that we have a new parameter here, the fallback triangles. Okay, and the other one, fallback vertices. All right, that is the new polygon count. Okay, the first one 403,000, the other one 200 over 200,000, and the other one over 4,000, the other one over 3,000. Okay, now it is already an object with Nanite. We can close it. If we go here in lit, Nanite visualization and overview, now we can see that the couch here, it was transformed in Nanite. Look, we can see the triangles, the clusters, the instances. Okay, masks if there is masks, overdraw, that is how difficult it is for this material to be created in the based on the repetition of one object that is behind another object, and the complexity here. All right, we have these things here. Well, here basically we have all the information of our object. Okay, after it was transformed into Nanite. Let's undo this process of the night. Look, select the couch and we click here and we apply it. Look, it has disappeared the other options. Now we just have the triangles, okay? If I put here in the night overview, we don't have the night here, okay? If I put here in cluster, it transforms my scene into clusters, okay? Keeping as cluster, let's see it here. Let's turn on the night. Let's see here the size of the cluster and apply it. Look, it is possible. It was transformed into the night. Okay, look. The night cluster. Look, I see that the couch now is the night, and all the rest is black. That means that in the night visualization, I can, for example, see or not what is the night in my scene. For example, as just the couch was transformed into the night, I can see the couch here. Let's get closer to this to the couch here. Look, I'm improving the quality. Look, and decreasing the cluster count. Look at this. Okay, so what is the ideal? Well, the ideal is to transform all the heavy objects in the night. Let's do this also to the other couch. A double click on it. All right, let's see, apply it. Let's see. All right, now we see that there is a difference there. The night visualization clusters. Look, we have these two objects that are the nights. Okay, we can optimize our scene like this. Piano, as you can see, it's really heavy. Look, let's apply it. Simple as that. Okay, this way you can transform your objects into the night. It's compiling the shaders. Okay, let's wait for this. Let the night visualization clusters. Now the piano is also the night. Okay. Nice. The bench here. Okay. Let's see. All right, this way we can optimize our scene. Okay. Everything that is heavy, we can transform into the night. Okay. However, the night has some limitations. For example, the night doesn't give support in mesh. Okay. And there is deformation in the mesh. Let's see it here. While it's opening there, let's see it here. Okay, we transform it into the night, piano, bench, two couches. Okay, let's hide. Let's optimize this one as well. Let's see, 300,000 polygons. It's a lot of polygons. Let's transform it into the night. Yeah, that's it. Okay, great. As one is the instance of the other, so there is no necessity to do for both because we already did for one. Okay, but as we brought to the scene and we copied inside the scene, Unreal already understands as an instance. So if we do for one, it's done for both. Here we don't put one at a time. Okay, we put one and we copy inside Unreal, and Unreal understands that they are instances. Okay, select one, 70,000. All right, let's enable the night, apply it. Okay, all right. Let's see, nanite visualization cluster. Look, now they are nanite. Okay, we're optimizing our project. Okay. Okay, press 80. All right, the letter. Uh, the board, let's take a look. I think it's not heavy, but we can use it to talk about Lodge. Yeah, LOD. Let's see these things here. The gravel. Um, okay. Uh, it is instantiated. There's Lodge here, LOD. So uh, we're not gonna use this now. We're gonna talk about Lodge in the next class, so we can use that. Okay. Don't worry about it. Okay, this thing here with chocolates. Let's see. If you're doing a project, a personal project, and you're adapting the concepts for your object, you can also transform the objects into nanite. Okay. Let's see. We have this armchair here. I think it's heavy. Let's apply the nanite. Let's transform into nanite. Okay, done. Press 8. Okay. Um, okay, let's enable the nanite. All right, pretty cool. This one is heavier, as you can see, 450,000. Okay, cool. Press 8. All right. Uh, in the bed, there is a lot. So we can adjust the bed and, for example, the gravels in the third class of this module. The next class, we're going to talk about LOD. Let's adjust. I think back there, there's an armchair that was adjusted. So it is already in the night. I'm sure about it. Perfect. Let's just hide this. Okay. What else? The table. Let's see. 1,000. It's just a little. It's okay. Here the coffee, the grains. 15,000. Let's use the nanite. All right. Now we can open our max here. Okay. Cool. All right. This one is already with nanite because it was instantiated. Press 8. Okay, the letter. Let's see this one. 8,000. Let's apply the nanite here. Let's enable. Great. This one, I think it's 7,000. Let's apply it. Yeah. Let's enable the nanite. Okay, great. All right. Here, these pens here. Let's see. This sink. Yeah, it's a lot. So let's enable the nanite. Okay. I don't think the lamp needs. Here, let's see. This bath tube. 27. It's not a lot, but we can apply. Can apply it. Great. Yeah. Okay, let's enable the nanite. Let's see. I think this one has LOD. Let's apply it here. This is an instance. So it is already correct. Another thing that we can enable the nanite, these things here, okay? Do you remember from 3D Studio Max when we were preparing the house to bring here? And we said that it was okay to keep a high polygon count because we're gonna use nanite. That is a feature that is gonna optimize the scene. So we can use nanite, all right, to optimize these geometries that are really heavy. Select them and apply nanite for them. Cool. Press 8. Here, this one. Okay, 700,000. It's a lot. Let's apply it. Yeah. Okay, that's it. There, just the doors. Here, let's see. Okay, 500,000. Okay, after we can associate the correct material, we're gonna talk about it in the other classes. Okay, let's focus on optimization. And little by little, we're having access to all the windows here. Okay, little by little, we're going to access the windows. Okay, look, the doors here, 200,000. Okay, let's apply it here in the night. Press 8. Let's see. Uh, let's see. Yeah, that's heavy. So let's transform into the night. Okay, cool. Yeah, that's it. Okay, yeah, it's okay. Let's see this here. It's a lot, so let's apply it. Okay, press 8. All right. This lamp is done. Let's see. What else? These elements here, let's see. They're not heavy. Let's see this here. It's a lot. Okay, let's apply it. If it's over 20,000, I think it's cool if you apply it in the night. Okay, if less than that, maybe you don't need to do that. Okay, look, 7,000, but okay, I'm gonna apply it. Less than that, maybe that doesn't, impact a lot on your project. But over 20,000, it's cool that you optimize. Okay, that you applied in the night. The bed we're gonna transform as well, but there is LOD, and we're gonna talk about it after. Okay, here, up here, let's see, 200,000. It's a lot. Yeah, that's it. Cool. All right. Now let's see. Control plus 8. Okay, let's see all the things in the scene. All right, let's see. Okay, lit. In a nice visualization cluster. Look, all these elements now, they were transformed into the night. Okay, look at this. As I get closer or as I move away, it's different. So let's see the impact that it has. Let's see, let's take a look in our FPS. Okay, let's see the piano here. Look at this. Our FPS is more like 120. Okay, it's in the night. Let's undo the night. Okay, let's apply it. Okay, it's a heavy geometry. Let's see. 120. Let's copy an instance, 2 instances, 3 instances, 4 instances. Let's see. The instances of piano, we can look. The instances here, it's copying the instance. Actually, it's not making copies. Look, it's 110 FPS. Let's select the piano, all of them. Let me see here. Okay, let's see. And the frames, 92. Okay, let's create another copy. Oh, it's a lot of pianos in the scene. Look, 92 frames. Let's see, 80. Let's see, 70 more or less. Okay, 80, 70 frames. We are with a RTX 3080. Okay, it's it's kind of strong for the year of 2022. Okay, 70, almost 80 FPS. Let's bring here. Okay, let me close it here. Control plus V. Okay. All right. No, Nanite. Okay, 75 more or less. Let's transform into Nanite. Okay, enabled. Let's apply it. All right. Immersive mode. Look, 100 frames, 110 FPS. We got almost 40 FPS. Okay, almost 40 FPS. Okay. Okay, I'm gonna enlarge this more, and I'm gonna duplicate the amount of pianos. Let's see. Let's duplicate there. A lot of pianos here. Immersive mode. Let's see. Okay. We can see a lot of pianos here. All right, let's put more, even more. Okay. Okay. Yeah, that's it. Let's put more pianos here. Let's see. Let's see here. It's gonna depend on your GPU. Immersive mode. Look, it almost didn't change from 110. Look the amount of pianos that we have here. Look, that's a lot. We have a lot of pianos here. Look at this. Imagine this is a software of modeling like 3D Studio Max, Maya. It's impossible. Like, if you don't transform these objects here, hardly you're gonna be able to put all these objects, these elements in the scene. Correct? Look, we created copies. Okay. Let's transform then into no nanite. All right, let's get back here. More or less that angle that we were. Okay. Where we had almost 100 FPS. Look here, a lot of pianos here. I'm gonna save the project. Okay, and maybe Unreal can close by itself. And if it's not the night, the chances are gonna be really high of Unreal close. You know, that Unreal closes. Let's see. Let's disable the night and apply it. Okay, look. Now we have 30 frames. Look. 28 FPS. Look. When the object is not in the night, we lost like 70 FPS. Okay. As we saw, when we transform the object into nanite, we can get a lot of FPS, double time, triple time, you know. So look, if for example one piano has like 300,000, we have, I don't know, 300 pianos here. We have millions of polygons here. Okay, and that made our FPS get lower. Let's get back to the night. Okay, enable. Okay, we got it back. Okay, 90, almost 100 FPS. Okay, it's very important. Okay, and very smart to use Nanite. Okay, So when you can, make sure to transform into nanite, okay, your objects. Let's see here. We have a lot of elements there. Let's erase them with Alt. Okay. Let me see. Select. All right. Let's see. Okay. Erase all of this. Okay. Erase this. Okay, this one as well. Yeah, erase. Erase. Let's see what else. Okay, let's hide the ceiling and see what we can see. Okay. The walls as well. Let's see. With 8, the letter 8, I'm hiding then. Okay. Let's see things that we copied that we shouldn't. Let's see. This here. Let's see what else. Let's see. This here. Look, I think. Oh yeah, this here. It looks that's it. Do you think it is correct? Let's get back to the scene. Okay. Yeah, I think that's it. Maybe we can see something lost here. Okay. Control plus 8. We got everything back. Yeah. Okay, let's hide this. This one as well. Look. Okay, so we understood that nanite is very cool, very useful, very important to use. However, there are some limitations, okay? Some type of objects that it's not possible to use nanite, okay? Because of a limitation in the technology. For example, max here, I'm gonna create a box here, and we take this box to there. Let's see, let's put here. Okay. Look, I want to put a modifier. Let's put here a modifier. A normal, for example. No, not a normal. Actually, let's see. In noise. Okay. Let's put in 2 centimeters. Let's decrease the scale. Okay. Nice. And let's create an animation for this. Okay, let's see. 0 to 100. Let's see. We're going to increase, actually decrease a little more here. Okay. Look at this. Look. From 0 to 100, we're going to decrease. This type of modifier, the geometry, or this type of modifier in the geometry, for example, let's see. Here. Okay, let's put here. Okay, let's bend this. If I click on these objects and convert to polygon, and export to Unreal and transform into nanite, it's gonna work. Unreal is going to understand, and it's gonna transform it into nanite. But if I take these objects as an animation to Unreal, I mean, like, uh, with these deformities in the mesh, what's gonna happen is that uh, if I take this animation and take to Unreal, it's not gonna work in nanite, because one of the limitations of nanite is it cannot have a modification in the geometry. Okay, so for example, let me see if we can export this to there. I'm gonna export this as let's see, let's see, I'm gonna save it here. Let's see, I think it can be here. Noise, okay, from 0 to 100. It's great. Yeah, it's close to the zero of the word. Okay, 200, maybe it's gonna be too heavy. Let's decrease a little bit. Let's try to put 100. Maybe 75. Let's take a look. Okay, let's see. Look. Let's see. 200 megabytes. Okay. Let's save it in case Unreal closes. Okay, let's see. Content browser. Let's bring it here. Let's see. Geometries. Import. FBX. Noise. Alembic. Okay. All right. Some things here about animation. That is not our case now. Okay. Yeah, and import. Okay, let's see. Okay, let's put in the scene. Let's see. Look. All right, it's here. Cool. Let's make it bigger. Let's put a white material here. Okay, cool. Let's click here and simulate. Look, you can see that the animation is happening, correct? So you see that there are deformations in the geometry of our object, and Nanite doesn't support this. You could transform this in Nanite, but you changed cluster here, it's not gonna be visible, okay? Because the nanite doesn't have deformation the geometry, okay? And actually, I cannot show you the deformation happening, okay? Because this object of the type Alembic, the details are different. I should have brought in FBX as an skeleton, but we can see here that object that has deformation in the mesh, it's not possible to use nanite, okay? So if you bring a character here that is walking, for example, a dog here that is walking here, if I have deformation in the mesh, like if he moves the head or the arm, nanite is not going to be possible. Another thing that is not compatible with nanite are vegetations in general, because nanite doesn't give support, for example, to materials that are translucent, okay? Materials that are transparent, uh, Nanite doesn't give, for example, support to materials that has a map of opacity, like those maps in black and white, where black is the image and white is opaque, okay? So it's not transparent. Nanite doesn't give support for this type of things. Actually, Nanite doesn't give support for most of the objects. Nanite gives support for objects that doesn't have deformations, okay, and that uh, doesn't have transparency, okay, in the composition of the material. All right. So, so if you identified in your project that you have objects that doesn't have transparency or deformation in the mesh, you can transform them into nanite, okay, because they will work, all right, and they will be optimized, okay. All right, so let's transform the table. Cool. All right. So, uh, if it's possible, transform your objects into nanite. As we did with the piano, you will have infinite amounts of furnitures, and there won't be any impact. I mean, not a really expressive impact on your FPS. So let's finish this class. Okay. We put nanite in some models, and in the next class we're gonna talk about LOD. Okay, that is the level of detail. Okay, see you. Nice. Okay, so now let's talk about LOD. That is the level of detail of our model. As the night, it optimizes our model. It increases the amount of polygons or decreased based on the distance that I am from the model. Do you remember that? Look, the night cluster. Uh, the closer I am, more clusters. Okay, if I'm more distance, less clusters. The LOD uses the same principle. It optimizes the geometry of my model with a difference. Basically, it doesn't base on clusters to optimize our model. It bases on the polygon count of my model. For example, let's select here. For example, let's access this model. Look, I think there's a lot here that were added. So let's decrease this and let's remove the lots, okay? So that we can make it together. Okay. I'm gonna go here, node, one here, and we're gonna do this process. Hold on. Okay, let me see the original value here. Let's see. Let's see. I'm gonna put 100. Okay, we're gonna talk about it. Don't worry about it. Cool. So I just removed the lot. Let's suppose you brought your model, your object. Oh, I forgot to tell you in the last class about LOD, lot, is that besides enable or disable the lot, here in the details, you can enable or disable the LOD when you are going to import your model, okay? Let's suppose we're going to import this frame, let's say. So we open it. Here, when you're going to import, you can click here, build nanite, and it's going to transform our frame in nanite. Okay, look, it has brought here the frame. It was already transformed into nanite. You see this? So if I take this frame, for example, and put in the scene, cluster, it is already nanite. You see this? because we transform it into nanite when we were importing the model. Okay, I'm gonna import a couch here. Right button, import. Let's suppose this is a couch. Let's say open it. I can enable or disable nanite. Okay, it's up to you if you want to bring the object with the nanite or not, or transform it into nanite here inside Unreal. Okay, you say when I use one or another. Well, if you have a GPU or more basic, you can bring this object as nanite. Okay, because if you have a lot of objects in the scene, maybe you're gonna lose a lot of FPS before transforming to nanite. Okay, in case you don't have a lot of objects or you're gonna build your scene inside Unreal Engine, you can do it after. Okay, you're gonna realize that. Okay, if it makes sense to import before or inside Unreal. Okay, basically, if the project is really heavy with a lot of furnitures and everything, and the project is already done and you're importing with Datasmith, for example, we're gonna talk about it after. You import with nanite. Okay, if you have a project that you're bringing the FBX all done and you have a lot of furnitures and you're not gonna build the scene inside Unreal, so there will be a lot of furnitures, transform into nanite. Okay, in the importation. Okay, but if there are a lot of objects in the scene at the same time, you can transform into nanite during that process. Okay, you can choose both. All right, let me see it here. Okay, let's delete this. Okay, let's get back to LOD. Let's see, what is LOD? Well, the LOD, well, as the night, as I get farther, I get closer, it increases or decreases the polygon count. Okay, increasing or decreasing the quality. Let's double click on it, on the little bird. Okay, here I have some information. For example, the triangles, the vertices, the UV channels. Okay, the current screen size. So, and the lot. Okay, how many lots I have and in which lot I am. Let's get closer here to our model and see wireframe. Look, here I can see the triangulation of the bird. Look, if you go here in the details, besides being able to change the material associated to the board, we can enable or disable the nanite. We also can enable or disable the LOD. For example, let's see it here. LOD settings. Okay, look, we have a group here, LOD group, that we can choose all of these here, deco, foliage, high detail, and all these options here. So we have these parameters, okay, that are going to adjust our object, okay, the LOD of our object based on the theme that we choose. And what is the LOD? Well, creating LOD, adjusting the amount of polygons based on the size and the distance. Let's choose, for example, this one. Okay, that is one that I recommend. All right, look, that's gonna leave this message here. Changing LOD group, we will override the current settings with the default. Okay, we're gonna go. Keep going. Okay, it's creating the LOD of our model. You can see that it has decreased the polygon count here. Okay, let's remove the LOD. Look, 1 and apply it. Look, the amount of polygons, the triangles. We have like almost 11,000. Let's put it again. Okay, we transformed our model. Look, now we have 1,364 triangles. Okay, but it's not adjusting based on distance of the object. Well, down here, we can use this option here, auto compute LOD distances or not. Look, we have these options. So let's compute manually. So I'm gonna uncheck that option and look, LOD picker on the custom. Let's enable here. So it's gonna tell that I have the LOD 0, 1, 2, and 3. Well, in the 0, let's see what we have. Reduction settings. Look, let's see. We have here some parameters. Okay, the percentage, percent triangles, and the screen size. Let's see the LOD1. We have in reduction settings the percent triangles, okay, and the size. In the LOD2, we also have the percent triangles and the size, and the 3 is the same thing, okay? Same thing, percent triangles and screen size. You can notice that it decreases the percent triangles. So LOD in the 0, LOD 0, that is the one that we are here, 0. It's considering that the percent triangles is 100. When it gets the LOD1, it's gonna consider that the percent triangles is gonna be 50. It's gonna be the half of the original one, okay? If you have like 10,000, the half is gonna be 5,000, okay? So let's take a look. If we see the LOD1, look, 5,000. It means that this distance from the object, it transforms the polygon count to the half, all right, of the original value. That was 10,000. The half, like 50%, is 5,000, okay? Let's move away a little bit to see the LOD2. It means that it's using like almost like 25% of the amount of the original. That was like 10,000, okay? So as we can see, the value here. Let's move away a little more. LOD3, it's saying that it is using 12.5% of the original one, okay? The amount of the polygons, okay, that was like 10,000, all right? So as we can see, the amount of triangles here, and it adjusts based on the distance that I am from my object, okay? Look, I can change it. So if I think, oh, it's too close to, or too far, I can adjust this, okay? We can go in screen size, and we're gonna say that when I get to this distance here from the little bird, the current screen size, this distance, I'm gonna put it here in 0.41. I want that it gets 50%, okay? It means that when I am with the LOD1, I want 100% of the triangle, okay, percent triangles. When I get the distance of 0.41, look, I want to go to the LOD1. When I get to the distance, for example, of like 0.22, I want that it gets the LOD2, okay? Let's move away a little more. When we get the distance of like 0.11, I want this to get the LOD3. When I get, let's see if we have more LODs. No, it's done. Okay, it's over. So let's recap this. I'm gonna say it again so that you can understand this better. So from the 0.41, it's gonna get the LOD0, okay? Look, like this. Look, it's changing here, as you can see, 0, 1, 0, 1, okay? So when my object um, gets like an error of 0.41 inside my screen, that's gonna decrease the polygon count to 50%. Okay. So for example, when I see the object like this, 0.41, that's gonna decrease the polygon count, the amount of polygons. Okay, because I don't need a lot of details when I get to this distance. Okay, when I get even more distance like this, when I move away, like close to 0.22, it's gonna decrease to 25%. Okay, look, it's changing. Look, so the amount of polygons is gonna decrease. Okay, when I get the distance where it gets 0.11 of space in my screen, it's gonna decrease, it's gonna reduce even more. Okay, as you can see, look. So let's decrease more. For example, when it's in 0.41, it's gonna be like 10%, okay, a polygon. When it's 0.22, we want 7%. When it gets 0.22, no, 0.11, we just want 1% of polygon. Okay. Okay, it's applying. Look at this. Look. You see this? As I move away or I get closer, it's gonna decrease or increase the polygon count. I'm close to the object, I'm gonna film or do something like that close to the object, so I have a lot of polygon count. I'm moving away, the polygon count is gonna be decreasing. Okay, this way you optimize your project. Okay, let's suppose you have a project here in the scene where you want to optimize the objects with LOD. You're gonna access your model, for example, the couch. We're gonna remove the niche. Oh, and I don't want to optimize with nanite. Okay, I want to optimize with LOD. So you choose a group. Okay, because it already creates the LODs for you in an automatically way. Okay, so the polygon count, the distance, but you also can adjust the amount of LODs manually here. Okay, but in case you don't want to create, one that was predefined, well, you're gonna adjust manually the distance, the polygon count for example 5 LODs if you want, or if you just want 2, you're gonna type the distance and the polygon count manually for the 2 LODs. Okay, I select here and it creates for us by default where it's gonna calculate the distance of the object and also the polygon count for this object. Okay, based on the size of the object and the distance that it is. Okay, in the beginning it looks kind of confusing, but as you're doing this, it's gonna be easier for you. Okay, don't worry about it, just keep going. Okay, so let's wait this process. Okay, it has processed the LOD. So look at this. Based on the distance, it changes the LOD. Look at this, 1, 2, and 3. As you can see, look. Okay. So let's see it in triangles. Look at this. You see? We can adjust, yeah. Let's uncheck the distance here. Let's adjust manually. Look, custom here. Do you remember that? Let's 0, 1, 2, and 3. Well, in this distance here, 0.8, I want 100%. Okay, let's move away a little bit. in 0.64, the large one, 0.64. The screen size, I want 50, no, 30%, okay? After we're gonna apply it, don't worry about it, okay? Let's move away a little more. In 0.45, I want 15%, okay? And let's move away a little bit. In 0.35, I don't want 12%. I want 5% of triangles, okay? Let's apply it. Okay, let's wait to process. As this model is heavier, it's gonna take a longer time, okay? All right. Meanwhile, I'm gonna open for us here in KeyHouse, and I'm gonna show you that inside another project, the lots happening in a lot of objects at the same time, okay? Okay, it's processing here. Okay, nice. It has already processed and it's opening the other project. Look, let's get closer and move away. As you can see, 400,000 and 120,000. As you can 60,000. You can see the amount of triangles here. Okay, let's put it here. Look, you don't even notice when you're distance that it is with a less amount of a polygon. You don't even notice that. Look, so it is a really good way, a really good feature so that you can save polygons, okay, as you get far from the object, okay? And it gets back when you get closer, the polygon count, the amount of polygons, okay? And it does in an automatically way, okay? You just have to adjust here, okay, the amount of polygons that you want for each LOD and the distance that it's gonna take to change, okay? For example, in this case of the LOD0, it's gonna change in 1. In the LOD1, it's gonna change when it gets in 64. Okay, look at this. Look at this. It changed, okay? In LOD2, in 45. Look at this. 45, it has changed, okay? In the LOD3, look, 35, it has changed. Okay, this way you can adjust the quality that you want, okay, based on the distance that you are from your model, okay? It's very similar to the Nanite, but there's a basic difference that we're gonna talk soon, okay? It has opened our project of KeyHouse. Okay, let's see. Okay, nice. So let's close it here. So it was done LOD on the couch, okay, and also on the penguin, okay. If we move away, we can notice, for example, there's a moment where you cannot even see the feet, okay, the last LOD that we reduced to 1%. For example, wireframe, we can see, look, in this scene, we have already objects with LOD. For example, look, the gravels here, you can notice this. As I get far, as I move away, it's decreasing the polygon count. As I get closer, it is increasing, okay? Do you remember that we migrate these gravels from the project of KeyHouse to the project of Piano House? Do you remember that? For example, here in KeyHouse, everything was made with LOD because in Unreal Engine 4 doesn't support Nanite, okay? Nanite is just on the Unreal Engine 5, okay? So in Unreal Engine 4, they were done by LOD. If I put here wireframe, we can see the polygons, okay, increasing and decreasing. Look at this. You see this? Look, here you can see a little difference. So they are the LODs that are happening. So you ask me, Dennis, but all the models of this scene, do they have LOD like happening? Yes, all the models they have it. Okay, it was made LOD for all the models. Okay, because the only way of a big project to be done, to be introduced in real time, is like being very optimized. Okay, for example, here in the grass wireframe, let's see, there is LOD on the grass as well, as you can see, as you can notice. Look at this. If I get closer, increase the polygon count. Okay, in the trees, same thing. Okay, as you can look at this, it's decreasing the polygon count, and it's increasing now when I get while I'm getting closer. This way, we can we can get better FPS. Okay, without sacrificing the visual quality. Okay, that way we can optimize our scene. Okay, it's really important. Okay, cool. So here in Piano House, it is already with models with LOD. Okay, because they were migrated from the key house. Okay, so by seeing that, we can understand that in the process of migrate, it migrates uh, all that is associated with details of the object. Okay, everything that is related with this object is gonna go with this on the process of migration. Okay, the materials, the textures, the LODs. Okay, look at this, the LODs happening. Look, I'm gonna increase here the camera, the speed. Okay, look, 1, 2, and 3. LOD. You see this? Look, it's decreasing the quality. Now it's increasing as I get closer. Nice, right? Okay, so that shows us that if I have a project, for example, this piano house, when we finish the course, uh, it's gonna have optimizations with LODs, like also nanite optimizations on the textures, materials that are gonna be applied, textures on the materials. Okay, so if we migrate, for example, this arm chart to another project, in the other project, we won't need to reconfigure the nanite, the LOD, the texture. You know, we will not have to do that because it was already done. Okay, so when I migrate from one project to another project, everything is going to go with the model. Okay, everything that is associated with the model is going together. Okay, so you don't need to do this process of optimization all the times for the same model. Okay, so if you migrate to another model, it also goes with the model. Important thing, you cannot use nanite and LOD together, and we identified that nanite has the limitation of not having deformity in the mesh. Okay, and not, for example, opacity map. Okay, for example, when we work with vegetation, look at this. Here in the key house, we have vegetation. All right, for example, grass and these things here. So what does it mean? Well, it means that I cannot use nanite, okay, on the vegetations. Why not? Well, if I open the material here of the vegetation, I see that besides the texture, we have uh, a opacity texture, okay, where what is black is transparent and what is white is opaque, okay. So the night doesn't give support for materials, okay, of the type translucent and of the type that it uses opacity maps. So you cannot use nanite, for example, for vegetation. Besides, you can notice that the vegetation can moves with the wind. Then uh, it is giving a little deformity on the mesh. So nanite doesn't give support for this. Then for optimization, for example, of vegetation, you have to use LOD. Okay. Oh, I got it, Dennis. So if I have furnitures or objects that are not transparent, that doesn't have opacity maps, I can use the night. Okay, and they are not going to move. That are not. I'm not gonna have deformity in the mesh. So and also that doesn't have an animation of deformity, so I can use the night. And when I talk about vegetation, I can use LOD. Yes, exactly. When you work with vegetation, you can use LOD, okay? Because as you move away and as you get closer, it's gonna increase or decrease the polygon count. When you work with furniture with a high polygon count, you can work with nanite, okay? So our piano house will have objects that we're gonna optimize with nanite, okay? There are gonna be these furnitures that we have here, and also with vegetation here that we're going to use, that we're gonna optimize with LOD, okay? So here we're talking about LOD, but let's see here the gravels. Let's transform it into nanites because there is no deformity in the mesh and there is no opacity map. So we can remove the LOD that we learned, okay, in this class. It's like, let's put known here. Look, it was typed 6. Okay, 6 times it changed the LOD. It was very optimized. Okay, so let's leave it in 1. Apply it. Okay, we removed the LOD. Okay, the 6 lots. Let's leave it 100%. I want a very detailed rock, these gravels here. So we can leave it like the night because there will be no deformity in the mesh and we will not use opacity map, okay? So we can transform into nanite. Let's enable nanite because I took the lot off and apply it. 53,000 and now it's 20,000. It didn't really get better, like, yeah, but it's okay. Yeah, lit, nanite, cluster. Look at this. These ones here. As you can see, there are some that we didn't do. Let's see. This one was done and the other one wasn't. Let's see. We can remove the lot here and this other one here because this is another object. Okay. Let's remove the lot for known. Let's leave in 1 here. I don't want more than 1 lot. It's gonna respect this one, that is the first one. Cool. And let's get back here 100% in the lot 0 and apply it. Perfect. Yeah, that's cool. Let's enable nanite and apply it. 26,000 there. Okay, all of them have LOD. Oh, oops, actually nanite. So I move away. That decreases the quality, and when I get closer, it increases the quality, the clusters. Okay. You see that in the visualization of the night, I don't see the lots. I don't see the bird there because it's not the night, it's lot. And the couch, we changed from the night to lodge, okay? But it doesn't make sense the couch be lodge because it's not gonna move. There is no deformity in the mesh and there is no opacity map. So let's remove the lot that we did to learn how to apply it. Okay, let's put none, one here. Let's put one and apply it. While it's processing here, I'm gonna get back here to the key house, and here in Unreal 4, as there is no nanite here, it doesn't exist here, this technology on Unreal 4. So everything here has lot because everything has to be optimized. For example, in vegetation here in Unreal 5 is gonna be lot because nanite doesn't give support for deformity in the mesh, and materials with opacity map, like in this case with the trees. Okay, for example, the leaves of the trees, they have opacity maps. Look at this, the leaves of the trees, they have opacity. Okay, opacity map. Okay, let's see, let's enable nanite and apply it. Okay, cool. The little bird here as well. Let's remove the lot. Let's put, oops, let's put known here. One, apply it. Okay, one lot only without any group. Okay, there's no way to customize here. Okay, let's see and apply it. Okay, you see that? The night clusters, look, the little bird and the couch, they are nanite now, and also the gravels. Okay, as they are instances. Okay, like the others, they are as well. Cool. Yeah, let's get back there. Perfect. Okay, so take this file of Piano House and try to transform into in your project everything into nanite. Okay, or try to transform everything in your project into lot so that you can try it, you see the benefits of one of the other. Nanite has more benefits, okay, because you can have infinite repetitions of objects without having a huge impact on FPS. Lot, it reduces the polygon count of the object, but the more the amount of objects that you have in your scene, it is still computing that 1% that you left. Let's suppose the 1% is like 1000 polygons. If you have 10,000 objects, you have 1 million polygons. Your scene is gonna get really heavy, mainly when we work with vegetation. Vegetation is a problem when we work in real time because it decreases the FPS. You're gonna notice that in our project here, a lot of things are gonna be nanite because they're gonna be better, efficient, the visual results gonna be better, but some things are gonna be lot because of the limitation of of the night, like the deformity and the opacity map. So try to transform everything in lot, practice this, and you're gonna get better. I'll see you in the next class where we're gonna talk about texture optimization. If you have any doubt, just leave in the comments or get in contact with us for the support channel or on our Facebook group. Okay, so see you. Nice. In this class, we're going to talk about optimizations, texture optimizations, okay? As in lot and also in the night, we can optimize the texture based on the distance that I am from the texture or not, okay? Which means that I can make the texture with more resolution as I get closer or with a less resolution as I move away, okay? Unreal does this in an automatic way, okay? It's a feature inside Unreal that optimizes the texture based on the distance that I am from the object. As long as my texture is a multiple of 2, for example, from 32, for example, 32 for 32 of resolution, we're talking about resolution. For example, look at this, 32 for 32 of resolution, okay? After 64 for 64, for example, 128 for 128. So if my texture has a resolution multiples of 2 based on these measurements, like 32 for 32, 64 for 64, 128, or 264, 1024, 4K, or 8000. So if my texture is based on these measurements, it's gonna apply in an automatically way the LOD in the texture for us, okay? And it is an optimization that is automatic, okay? Let's take the wood texture here. Let's open the material and double click on the texture. Okay, we are here in the details of the texture, okay? As we have the details of the materials, details of geometry, we also have details of textures, okay? As for base color, as for normal, specular, okay? Look at this, specular here. So inside the texture of base color, we have some information. For example, the resolution that it was imported, okay? So this texture was imported in 2048 for 2048. Remember the multiple of 2, 128 for 128, 1024 for 1024. So it was imported for 2048 for 2048, okay? So automatically it has a LOD applied. As I move away, the resolution is lower, okay? And as I get closer, the resolution is high, okay? It's higher. So it was imported in this multiple of 2. So we imported and it is showing in 2048. When we imported this texture in multiple of 2, it enables MIP settings, okay? And by default is from texture group, okay? If this texture is in multiple of 2, there is no optimization of LOD, okay, in an automatically way. So let's try to find some texture here that is not multiple of 2. I think this here possibly cannot be. I don't know. Oh, yeah. Okay, so this wood is a really huge texture. After we can decrease this. Okay, 10,000 for 3,300. So it's not multiple of 2, okay? It's not like 2048 for 2048. But you ask me, what if it's 2048 for 1075, for example? No, it cannot be like that. It has to be, for example, 1024 for 1024, okay? What if it's 1075 for 1075? No, it cannot be like that. It has to be like 1024 for 1024 or 2048 for 2048. These numbers, yeah, it's gonna enable the from texture group. You're gonna see that I'm gonna put it and it's not gonna activate. It's not gonna enable because Unreal doesn't understand that this texture is multiple of 2, okay? So in these textures, because it's not multiple of 2, there is no optimization of LOD, okay? So in this texture, if it's multiple of 2, there will be optimization in the LUT of the texture. Okay, I can change it here, as you can see, from texture group. Okay, the LUT of the texture is enabled. Okay, sharpener, sharpen is a type of optimization with more definition or less definition. Okay, or without definition, without optimization. Okay, from a texture group with optimization, as long as it is multi-hub 2 based on these sizes, like 2048, 1024. Okay, this texture has LUT automatic. Okay, what if I want to remove? Well, you can double click on it, no map. All right, so I don't have LUT anymore. If I want this, I put from texture group. By default, if it understands that it is multiple of 2, it's gonna enable LOD. Okay, let's take a look here. We have variation on the reflections. Let's see if it's multiple of 2. Let's see. Yeah, it's multiple of 2. It is already with LOD in automatic way. Okay, yeah, it's okay. Multiple of 2, it is with LOD automatic. Okay, the ladder of the armchair, let's take a look. 2000 for 2000. No, it's not 2048, so it's not gonna enable the from texture group. Okay, or I go to Photoshop and transform the resolution like 2048 for 2048, so then I can have the LOD. Well, it makes sense to do that. Well, let's go to Photoshop and let's transform in 2048 for 2048. It's really close, so we can do it so that we can have LUT on the texture applied. Okay, automatic, in an automatic way. Look, I already found here furniture. It's here. Let's take a look inside piano house. FBX furniture. It's here. I'm gonna open it with Photoshop. Okay, it's here. Let me close these other windows here that we have opened. Let's see. File, new, 2048 for 2048. Okay, to be a multiple of 2. All right, Control plus A and Control plus C and Control plus V. Let's see. Okay, yeah, 2048 for 2048. Let's see. It's like this. Let's paste inside our folder. Let's call it texture a ladder base color. Great. Yeah, cool. Let's see. Okay, let's see here. Content. Let's import again this texture. Look, the content here, the texture is there. I'm gonna close it here. This one. Okay, this texture here. Right button, re-import for a new file. Texture, look, it's here. Let's re-import this. You're gonna see that it's gonna change the number there, and it's gonna enable the from texture group because it's to 2048. Look, it has opened 2048 for 2048. Now we can enable the optimization, the LUT. Okay, I can change here from texture group. Perfect. Now it's cool. Yeah, as I get closer, more resolution, 2048. As I move away, less resolution, like 1024 for 1024, and the other resolutions based on the distance. Okay, so it's good that we do it. Okay, take a look at the textures. If they are multiple of 2, this one here, for example, over 4K, it's huge. It's a huge texture. We're gonna talk about it. Okay, how we can decrease the size of this texture. All right, let's take a look here. Let's take a look. 2048 for 2048. Yeah, there is a lot on the texture. This one, um, we imported in 2048. Yeah, we're gonna show in 1000 for in 24. We're gonna talk about it. Don't worry about it. Okay, let's take a look here. Probably it's not multiple of 2, so there is no from texture group. You can, for example, transform in 1024. Okay, because it's very close. Yeah, that can be an option to transform into 1024. Cool. Yeah. Let me see if we have some more texture here. These gravels here. Let's see. It's a white texture. Yeah, just a white color. So let's see. Let's apply the wall texture, and let's apply it on the gravels. Let's take a look. I open here. Let's see, and let's use the wall material, white wall, and this here. Yeah, nice. Look, the material is more beautiful. We have more variation, like in the reflection. Okay, it's more beautiful. Yeah, this material. Yeah, that's better. And also have the texture that is multiple of 2. Yeah, nice. Let me see here. We have a texture here as well. Let's see if it's multiple of 2. Yeah, cool, great. And here as well. All right, nice. Yeah. So Unreal is optimizing for us the textures that are multiple of 2.